So now we have the first pair of the cofunction identities. The first one is the cosine half pi minus beta equal to sine beta, and then sine half pi minus beta equal to cosine beta, right? And from here we can get the cofunction identity for the tangent, cotangent, secant, and cosecant. And let's move to the next page. So let's look at the tangent of half pi minus u, and this is equal to sine of half pi minus u over the cosine of the half pi minus u. And we know the sine of half pi minus u is equal to cosine u, right? And the cosine of half pi minus u is equal to sine u. So this fraction is equal to cotangent u. Okay? And see cotangent of half pi minus u. So by definition, this is equal to cosine of the half pi minus u over the sine of the half pi minus u. Okay. And then by the cofunction identity for the sine and cosine, this guy is equal to sine u, and this guy is equal to cosine u. So this is equal to tangent u, right? Now let's look at the secant of the half pi minus u. So by definition, this is equal to 1 over cosine of the half pi minus u, and cosine of half pi minus u is equal to sine u. So this 1 over sine u is equal to cosecant u. Okay, and the last one, cosecant of the half pi minus u is equal to 1 over sine of half pi minus u, and this is equal to 1 over the cosine u, and this is equal to secant u. So they are quite similar, right? Now let's put the angle u and the pi over 2 minus u in a right triangle. So this u and the pi half pi minus u can be the acute angles of a right triangle. Actually, we let u between the 0 and half pi. Let's see why the half pi minus u is also between the 0 and half pi. So now, suppose we have the u greater than 0 and less than half pi. Then we multiply each part of this inequality by -1. Then we get 0 greater than negative u and greater than negative half pi. Okay, so when you multiply an inequality by a negative number, you just switch the direction of the inequality, right? And then we add half pi to each part. So we have the half pi plus 0, so that's half pi and half pi minus u, and then greater than half pi minus half pi, that is 0. So now you can see this half pi minus u still between the 0 and half pi. So both the u and half pi minus u are acute angles, right? And in this graph, so they are the acute angles of a right triangle. So these two acute angles are the complementary angles, right? They are the complementary angles. And the cofunction, the CO in the cofunction is just from this complementary. Okay, because in those functions we relate this u to this half pi minus u, and these two angles are complementary. And actually, you can also use the ratios, okay, the ratio of the sides of this right triangle to derive the cofunction identity. For example, you have the sine u, and this is equal to opposite over the hypotenuse, right? You have the opposite over the hypotenuse, and this is equal to y over r. Now, how about the cosine of the half pi minus u? So cosine of half pi minus u is equal to adjacent over the hypotenuse. But for this half pi minus u, adjacent is equal to y, right? So you still have the y over r. So now both the sine u and cosine half pi minus u are equal to the y over r, so they are same, right? So you have the sine u equal to cosine of the half pi minus u. Okay, and similarly, you can get the other cofunction identities. So after we find the cofunction identities, now let's look at one example to see how we apply them.